So our first step, now that we've got our data constructed, is to apply the Fama and French three-factor model. What we're going to do here is pretty straightforward. First, it's going to be the return of the stock, and this is the percentage you multiply by 100. What we're going to do is subtract from the Fama page the risk-free rate. Okay, now we're going to go ahead, that's a monthly, or that's an annualized risk-free rate, or monthly risk-free rate, sorry. We're going to drag that down, and this becomes the Y variable that we're interested in. So it's the monthly return of the stock minus the Fama and French risk-free return that's here. And now we can use line nest. I'm going to show you a slightly different way to do this. We're going to come over here to data analysis, and we're going to do a regression. And my Y's are going to be my returns. Make sure that you're at the top of the page. So these are the monthly returns minus the risk-free rate for UTX. The X's are going to be my returns, or my Fama and French factors. I'm going to output all this regression information into a new sheet. And just go ahead and hit OK. So can align these guys a little bit. What I'm going to do is highlight multiple columns and then get them aligned. Okay, so we have the intercept. This is going to be under the Fama document, Fama data, market minus risk-free rate, then SMB, and HML. This is return on small stocks minus big stocks, and this is return on high book to market minus low book to market. So here are the coefficients that we're interested in. The intercept can or may not be interesting. Most of the time, in expectation in the future, you assume that you're fairly valued, so this would not be utilized. And again, this is in decimal percentage. Our next step we're going to need is the averages. So equals the average. And we'll come back here to Fama and we pick the risk-free or the market return. And I'm going to go ahead and drag this one over 3 places. So these are the averages for the values. And the reason we're using averages is capital projects go over a long period of time, typically. So your expectation, your expected return isn't a short-term average, but a long-term average. So this is the 5-year average of returns associated with UTX. And then the required rate of return on equity, which we would say is RE, return on equity. We just apply the equation with the averages. So it's equal to the intercept plus the first coefficient times the average of that value plus the second coefficient times the average of that value plus the third coefficient times the average of that value, which would be 0.55%. Now that's per month. So then our annualized would simply equal our monthly return, and we multiply that by 12. So the expected return on equity for UTX is 6.68% per month. And that's the solution that we're looking for. That's the answer to the question, what's the required return on equity over a long-term period, 6.68% per month. Now we're also going to need to have some equity information and debt information. You're just going to come here to Yahoo Finance. You'll enter your ticker symbol. Mine's again UTX. So the market cap is 95.3 billion. That's fine. So I'm going to say that equity is 5.3. And then we're interested in long-term debt. What's the value of long-term debt? We'll come back here to our number, and we're going to go to our balance sheet. And we can look at, say, 2011, which is the last year that we're interested in. And we have total liabilities of $3.9 billion, and current liabilities of 18.6. So I would just take 39.2 minus 18.6 because we're only interested in long-term debt. So again, that's 39.2 minus 18.6. So it's equal to 39.2 minus 18.6. So that's my long-term debt. To get the required return on bonds, you're going to come up here and say FINRA bonds, and we'll just click on this is the FINRA website for bonds. What we're interested in is the data center. And I want corporate bonds. I'm going to enter the ticker symbol, which is UTX. We're going to search on them. So here are all the bonds for UTX. There's quite a few of them. Now, if you're going to do this, quote unquote, the right way, you would consider every one of the bonds. What I'm going to do is just kind of take a representative sample of 3. That's all you need to do is take a representative sample of 3 bonds. And in terms of representative sample, you want to look at the coupon rates that are associated with them and kind of the years to maturity. So I'm looking at, a 9.3, a 9.3. So there's a couple of them around 9. So I'd say, so I'll just take this 9.875 as one of them. There's a couple here around 5. So I'm going to take 5.4 is another one. And there's a couple around 6, a couple around 4. I'm going to go ahead and take this 3.1 as the other one. So my numbers are 3.1%, and what did I say? Say 5.7, and then the last one here is going to be 9.3. And we're just going to average those guys. So then we're going to have equals 3.1 plus 5.7 plus 9.3, and just divide that by 3. Alright, and then to apply the equation, we just come here, and WACC is the value of equity divided by equity plus debt times return on equity plus the value of debt divided by equity plus debt times the required return of debt times 1 minus the tax rate. The tax rate is going to be 0.39, 39%. So we would just go ahead and apply that. So our WACC and that's just going to equal, again, it's equity divided by the quantity of equity plus debt times the required return of equity plus the value of debt divided by the quantity of equity plus debt times the required return of debt times the quantity of 1 minus 0.39. So there we go, 6.14, and that would be the WACC for UTX. You'll just follow the same basic procedure to find the WACC of your company. Thanks, bye.